In this video, I will show how to find the hydrostatic force exerted by a liquid on the wall of a container or anything submerged in the water. The formula that we're going to use is the integral from a to b of rho g h of x times w of x dx, where h of x is the expression for the height of this surface, or the depth of the surface under the water, and w of x represents the width of the surface. So in our case, we have a cylindrical tank, and we going to place the coordinate axis right at the top of the tank, pointing down, and we're going to pick some arbitrary slice, and in this coordinate system it will be x units deep, meaning the function representing the height will just be x. And now to find the width of this line segment, we're going to do some geometry. The radius of the circle is 5. Since this line segment is x, therefore this line segment will be x minus 5. Then using Pythagorean theorem, we can find the half of w, which is the square root of 5 squared minus x minus 5 squared. And the limits of integration will be from 0 and all the way to 10, which is the diameter of this circle. So the integral that we are setting up is from 0 to 10. Rho is 820 kilograms per meter cube. G is 9.8, and the expression that represents the height or the depth is just x, and the expression that represents the width is 2 times the square root of 25 minus x minus 5 squared, all that dx. And to integrate this, we're going to perform the couple substitutions. So the first one is, let's set t to be equal to x minus 5, then dt is dx, and the limits of integration are from -5 to 5. The reason we do the substitution is so that now we can recognize that this is just a trigonometric integral, or an integral which can be done by another trigonometric substitution. So here we have t plus 5 times 2, and here we have 5 squared minus t squared dt. The next substitution will be t equals 5 sine theta, meaning dt is 5 cosine theta d theta. Then square root of 5 squared minus t squared is going to be 5 cosine theta. and the limits of integration will be from negative pi over 2 to pi over 2. And after this substitution, the integral becomes from negative pi over 2 to pi over 2. Let's collect all the constants. 820 times 9.8 times 2. This, as a matter of fact, can be factored out. And what's left is 5 sine theta plus 5 times square root of 25 minus t squared, which is 5 cosine theta, and dt is another 5 cosine theta d theta. 5 can be now factored out again, so we have 820 times 9.8 times 2 times 5 cubed, and what's left is sine theta cosine squared theta and plus cosine squared theta d theta. Now each of these parts of the integrand can be easily integrated, and the derivative of sine theta cosine squared theta is just negative cosine cubed theta over 3, and antiderivative of cosine squared theta is sine of 2 theta over 4 plus theta over 2, and all that is evaluated from negative pi over 2 to pi over 2. Cosine of pi over 2 is 0, sine of 2 times pi over 2 is sine of pi, which is 0. Theta is pi over 2, so we have pi over 2 over 2 minus negative pi over 2 over 2. So this just becomes altogether pi over 2. So the final answer is 820 times 9.8 times 5 cubed times pi. And the units are, of course, newtons. So we found the force exerted by the kerosene on one end of the tank when the tank is full.